Now shows you the bullseye approach. That's the ring system and the orbits of the previously known satellites. As I said, the new satellites are in this region right here. Here comes the spacecraft. You'll see the spacecraft will be rolling a great deal. That's because in order to minimize the usage of the SCAM platform, we have rolled the space. Here's a stellar occultation. We observe the starlight, measuring it every 100 times a second as the star is observed through the rings. And that will allow resolving structures in the rings on the scale of about 50 feet. These will be very accurate maps of the shape of these narrow rings using the photopolarimeter. And we do that twice. This was one example of the stellar occultation. This now represents our best imaging of Oberon, which is the outermost known, previously known satellite of Uranus. Now you can see the spacecraft is turned upside down in a certain sense, but it will continue to maneuver in this way as we aim the cameras and other instruments at the various targets in the system. During this phase, we'll be, of course, taking images of the rings. We'll be taking numerous images of the atmosphere, trying to measure the wind patterns there, occasionally interrupting to take the best images of the satellites. This is Umbriel, and the third one out from the planet. And as we pass through the ring plane itself, we would expect, if there's a trapped radiation environment, that's where the maximum intensity in the magnetic field would be, and the maximum intensity in the radiation belts. This is now Titania, which is fourth out from the planet, and this is the field of view of the narrow-angle camera, which is to indicate how large the object will appear in the field of view. And you notice there were two images taken of Titania. As you know, the spacecraft is getting aligned so that we can best detect any plasma as we move through the ring plane. We'll also be taking images of the rings on edge as we go through the ring plane. This is Ariel, the second one out, and you can see now the object appears large enough that we have to start mosaicing it. And we also have to do image motion compensation because the exposures are so long that we have to move the spacecraft to compensate for the smear which will be introduced. And this is Miranda, the innermost previously known moon. This is the one we fly only 18,000 miles from its surface. We'll be imaging things which are on the order of ½ a mile across at closest approach. Now you can see we're moving on to the dark side of the planet. You can see the 9 rings, and it's during this time period, especially when we're behind the planet, we'll be able to image the rings and forward scattering. But before that happens, though, you'll see first the sun and then followed behind a small blue dot, which is the Earth. And we're sitting on the Earth watching. Here's the sun, there's the Earth. And from Earth, we'll be watching the radio from the spacecraft transmitted through the rings. And similarly, as the sun sets, we'll measure it with ultraviolet on the spacecraft, and as from the Earth, we'll be measuring the radio waves coming from the spacecraft. And we repeat the whole process again. As the sun comes out, we watch it with the ultraviolet, and from the Earth, we watch the radio beam as it comes into view again to Earth right here. And then finally, we watch from Earth the transmission through the rings of the radio beam from the spacecraft in order to measure the particle size distribution. And it's during this time period that we would expect to have our best view of the backlighted rings, of any lightning and auroral activity on the dark pole of Uranus.